assessment with a little Delphi. I'm Stefan Eggermond.
I'm Diego.
The problem we are talking about today is how do we start doing humane assessment. Humane assessment, we want to take a look at our software and not make decisions because we feel that something is wrong or that we think that we might be able to do better.
We want to decide knowingly.
Yeah.
And everyone makes decisions, so not only the managers, but the developers, the testers, everyone in the process of making software. Decisions require... You skip a lot. Oh well. Decisions require accurate information, so you should put some effort into gathering that information. And details are usually essential, so therefore assessment is a human activity, and you need to tackle each problem individually. You can't simply throw a general tool at it and then hope you get the answer you want.
We don't believe in
taking
the Gartner view of what technology to use and apply that to your problem.
But why want we talk you about Delphi? Why do we want to use that as an example and not Smalltalk, for instance? Well, Delphi is a typical language that is seen by management as legacy, since it's no longer popular, so the number of developers is decreasing.
It's no longer being taught at universities.
There is a problem with the continuity. There's now a company again that really supports Delphi, so it really puts in effort again, but there has been a time that wasn't really the case.
As an environment, it is still good enough to continue working with it. You have good refactoring now, you have unit tests, you have mocking frameworks, we have continuous integration for it. So, from a technical point of view, it's not really needed to replace it. But from a political point of view, in most organizations, you have a problem, and if you cannot get developers for it who want to develop in Delphi, you need to replace it at a certain point of time.
And from the money point of view, it's a bigger language than Smalltalk. More people know of it. It has been taught for quite a while, so it's a well-known language.
And we know it very well. We have been programming in it for a while, so we know where the weak spots are. Getting started doing humane assessments can be looked at from 2 points of view. You can look at it as a grassroots movement, and then you are just a developer finding that you should do assessment at your own code or at the code of your colleagues and try to do things.
But that only works when you already work there, and we want to sell a product, so we want it from the other side. We want it from the management level, from the strategic level that is visible to management.
And if you want to sell it, you have a problem. You need to build trust that what you are doing is the right thing. You need to have a low investment level to get started, and you need to get fast feedback on what you are doing.
Simply, you have to pull it out of your bag, show it to the management that it can solve their problems.
Basically you cannot start and say, I need to build a parser for a few weeks, and in a few weeks I'll be back, and then we will see what your problem is.
Maybe for some very big software company that's okay, because they already have the name, but not for small companies like that.
And Delphi is more popular in smaller companies than in larger companies, so that's a problem you really have. Yeah.
Well, you usually have a complex problem. The management perceives it as a problem, but they probably will have a hard time formulating what the problem actually is. So you have to ask a lot of questions in the beginning.
And what they see as a problem is most likely not the real problem or only part of the problem. And you have very wide in the whole organization why specific points are a problem and for who they are a problem.
So to get a problem better visible, what the exact problem is, it is usually a good strategy to shoot with hail, to have several fast experiments that are safe to fail.
If you want to know more about that, take a look at the work done by Dave Snowden on complexity. It's called Connecting. It's a framework that talks about problems which are simple. In simple problems, everyone can see what the relationship between cause and effect is. So you can apply best practice, and that's the way to do it. A more complicated thing is a complex problem. A complicated problem, and a complicated problem is something where you need experts, where it's not very visible what cause and effect is. For a more difficult problem is then a complex problem, and there you only can see with hindsight what cause and effect is. Because you have to do with multiple stakeholders and you don't know how the political situation between them is and what's really important in this company when getting there first time, you're likely to encounter a complex situation. Those different situations need different approaches, and for a complex situation we have trying things, getting fast feedback as a way to do it.
So, what requires low investment? How do we tackle the problem of low investment? Analyzing code requires parsing. Building a parse. There are two approaches you can do. You can either use or modify an existing parser. That can be, and when you look at the several languages, Java, Smalltalk, C, and Delphi, in Moose there are already parsers for those, so that's a good thing. And you can always also go the way that you use the native language. Native language has, of course, a parser and a compiler, so you might look into that one. Especially Java has pretty strong, good hooks to actually use in the parser.
And for Delphi you could use the Free Pascal compiler set, which has open source and which has parsing support. The other approach is to use island parsing and only take a look at the most interesting things for the problem you see at the moment, and parse that and solve that.
An example of island parsing is a project we ran that was a data conversion project. The original language of that was COBOL, and we only needed to read the data of the old system. The software itself wasn't really relevant how it was written or what logic was processed, because they only wanted to convert the data. So we had to look for the data definitions and parse those data definitions, and so we ignored most of the code, of the COBOL code.
Doing multiple experiments and trying to see what fits. When we start doing this kind of thing, we take a look at the dependencies which are there, trying to find code duplication. We take a look at what typical issues are, both for the language as for the typical legacy software problems. And we take a look at how changes are made in the software, what happened there.
Dependencies. Typical questions of dependencies is, do we have no source? How well balanced is the system? Is there one God class, or is the code spread around well? And how complex are the dependencies? Is it a very good layered program, or is it does it contain a lot of cycles in it? We can show something about the dependencies of few projects. So we have loaded already a few projects in our Moose, and just select the packages or Delphi units, it's the same. And in the right mouse menu, it recognizes this as Delphi, so we can have the dependency. Just show the dependencies basic. The normal one, two below it. Normal to cycles. This is what Moose gives you free out of the box. And well, as Petit Delphi is now part of Moose, I guess the other ones are now free out of the box as well. But
yeah, you see here that the size of the packages is not really the same for not divided well for this project. One of the packages is much larger than the others, and we also have things which are translated from C header files. If you only had automated and standard views and ways to deal with it, then you would have to make sure that you exclude those things, because being so large, they dominate the view and you cannot see what's really happening in the code people wrote themselves. So, what we do, we make a more specialized view on that.
so we do the units. Start with the units. And here you have some. Still, you see that some packages are quite large. I think you should press the minus a bit more. And here you can see we added more information, because in Delphi you have interfaces, which is more or less the header of the file, which says, okay, in this file these classes are defined and these methods you can use elsewhere, etc., etc. And then in the implementation the actual code is, and in the implementation you can specify again, okay, but I not only use that unit, but in my implementation I need that and that unit as well. So in Delphi you can have actually cyclic dependencies, because the interface
It's not allowed to be cyclic dependent, but the implementation may depend cyclically on another.
Yeah. So the green line are the implementation uses, and the gray lines are the interface uses. You see this project is quite complex. There are a lot of lines. And the Delphi classes, I believe, gives another look, because it limits it, and it shows the classes, and there you can see that some packages contain a lot of classes, and some packages contain a few very large classes.
This is one of the first things to look at, to just get a feeling of where things are in your code and if it's divided up well. And so we have here this very large.
I think that's the UML.
Yeah.
That's
That's the one which was so very large in the other two things.
So you see that in all three diagrams, UML models takes up a lot of space. So that's a good place to start looking for problems.
And on the other hand, you want to take a look at everything else but this, because you then can see more. Okay. Back to the
So the second thing that is a good thing to look at is the duplications. Also here there are a few general tools to look at it, and
The first order thing we always do is just run zip on the source code and see what happens. Delphi code has a normal range of compression which you should have if the code is okay. If it's much larger or much smaller, something strange is happening there. And then mostly we use Jute, the code, to find out which parts are copied and copy pasted.
Yeah, did you run the duplication on?
No, I don't think.
Well, you can run the duplication, the dude on the classes. Select all model classes, and then say utilities, compute duplication. It shouldn't take too long.
No, that's the
Wrong one.
that's the
Oh yeah, wait, we select the package UML models. That was it.
okay, yeah.
Because that was our interesting package. Yeah, you have to...
Where is it?
No, the packages. You have to select the
Okay.
packages, or the namespace doesn't matter, and then go down 8.
My mouse is not doing what it should.
You're scrolling at 2 points at the same time. You're doing it again.
This user interface.
No, models. Just right at the bottom. I thought. All classes, utilities, compute duplication. Is it already done? No, it's not already done. Ah well, we go back to the presentation and we show you the duplication sort after. It runs a while and then it
Tells you what is copied, and the duplication also shows what was copied but only slightly changed. So parameters changed or a copy and then 1 or 2 lines changed.
Typical legacy problems you should look for, can look for is whether there are multiple styles, either in architecture or in code. Well, the copy, paste and edit, well, or the duplication we already tested for differently, so we already tackled that more or less. Missing tests is a typical legacy problem. And low abstraction, which means you have a lot of code at low level, it's also a typical legacy problem. And you could also look at typical Delphi issues if you, or a typical language-specific issues. And when we look at the typical Delphi issues, you have, for instance, code written in form event handlers. Delphi has something that is called forms that you have, that you can in the project visualize the form you have.
Use a UI painter to drag and drop form fields on that.
And since you want your code separated well, you want the painting code in those forms, but not the main logic code. So typical problem is that the event handlers have a lot of code, which means that there's the main code in it.
And another way, a problem is that the standard style of working with Delphi is direct database access, not creating a domain model and using transaction script instead of domain model.
I think we should stick with, there's a list and we have the entire list here. But if you're not Delphi programmers, then you probably
So we can show what happens if your code written in a form event analysis. We have written a visualization for that.
Is the duplication still running? Oh well, interrupted. So when you go back to the white star, you close it and open it again. And then you have an old Delphi forms. We added that, and you can here now visualize the Event handler. And then you can see the red ones are the one that validate complexity rules. The length is the amount of code, the width is the complexity, and the complexity should be 1, maybe 2, but definitely not more.
So the white ones are 1, the yellow ones are 2, and the red ones are more than that. So we see that for most of the code it's pretty much okay, but here in this piece we have too complicated stuff going on.
This is the
Yeah.
and there you can browse the source.
And then you see here that this code is too long.
It's definitely worth a lot of ifs,
Yeah.
so it's definitely not what you want.
And the idea that if you start doing this, you take a look at your language and decide what kind of analysis you really need for this language specifically.
And there might also be a list of typical problems of the domain area. If you have a bank, well, could I?
Well, there you have the auditability things you need.
You have to log everything that might be done in an altered way.
And there are the things which have to do with the way the software was developed. You might be able to notice that at a certain point development was outsourced, or that multiple teams have been working on that. And depending on how that project was organized, you should be able to see what happened there and if that gives problems.
So, I believe that was the end of the presentation, and now we're going to dig in together. Code written in forms. Oh, yeah, wants to show you the arrays, changes, what you can do for changes.
We got some
great arrays. Oh, you loaded it in there. Okay.
A few years ago we started using this with a project done by Michael Ferrers to look at how code changed, and he analyzed 4 Ruby projects and took a look at their GitHub repositories and collected basically a big Excel file with lines for each change that happened, with each commit that happened, and in which method and which class of the project that was. And asked us, can we see how those projects were developed and if there are problems there. If you take a look here, you see how large the number of changes in each commit were for the committer, and so you see here that Aman has been doing lots of commits, has been mostly doing small commits, and some other people only made large commits at the same time. That might allow you to help people get better at making their commits small.
One thing you should all be aware of if you do this kind of things, don't make it too personal, especially not in the beginning, because you don't know the organization and it might turn into a tool that says, oh, you don't make many commits, you're fired. And you don't want to be responsible that on your first day. Because that doesn't make you very welcome there.
And in general, if you do humane assessment, you have to be very careful about how you formulate what happened with the code and your results, and make sure that you communicate that in a non-violent way, and allow people to learn from what happened, and make sure that they can do better next time, or making things visible in a project can be very dangerous. If management wants to kill a project, that can happen as soon as you detect lots of issues, or what is seen as lots of issues. And yeah, well, that stops a project pretty well. So this is also an example of an island parser, because this is only taking a look at the place where a change happened and how large it was. So
well, we actually got a file that already did collect that information, so we didn't build an island parser for that, but
we only created a model for this project with files with the changes. Yeah. I guess that was the fixed point.
And with humane assessment, humane assessment is an iterative approach. With each answer leads to new questions, and you have to be careful that not to explore every question, but to focus on risk and value, to really answer the questions that are important. And what's important is, of course, up to the organization, not to yourself.
We noticed that when doing analysis, you are going to do, we did lots of things which led to nothing, and the thing you have to show is how you could have gotten to the results you are getting if you had only taken the right choices in what you do. Then you can show to management how you would have analyzed the stuff without showing all the garbage and the things.
It's like the development process you take in university. It's a beautiful process, a very clean process. You know you're never going to achieve that process, but when you work in a company, it's how you report that the process has taken place. And in the same way you do humane assessment. You do a lot of things that don't lead to the desired result, but you show them how you fake it, you fake the process.
Any questions?
I have one, not really a question, but a remark. How does it work exactly? So you have a client, and then you propose your consulting service, something like that?
This was done before having a client for this.
No, but okay,
But,
but because my idea is, will that be useful once you did the first experiment? You determine the rules or what is interesting for this client. Will it make sense to couple this kind of thing with the continuous integration server like that? Each time a commit or new something is produced,
Yes.
this kind of diagram should be regenerated.
Yeah. Often. Yeah. There's Sonar tool, which
yes,
is
it's what
well known
I would
for
like to improve
being in
Sonar
computation. But adapting Sonar is not so easy, and making your own analysis with Sonar is not so easy. You could do that, but doing it with Moose is much easier. And of course you can use Jenkins trigger to do analysis again. Yeah.
So my question is, would that be, do you think that it could be interesting from a business point of view to sell this kind of stuff to clients, saying, okay, we will produce some rules that fit your business, and then we can have a solution?
I think that is a very good step, but not a very good first step. Because if you say that you will do that, then it will take you too much time before you can show results.
Yeah, of course.
Yeah.
And so so they won't buy your product because they say it's too expensive.
And in a way it's somehow conflicting with the use of sonar, because for those fixed things, they should just start by installing sonar and taking a look at their code through that. And when they then have questions about it, then they should probably start using Moose. And so it's probably easier to start with installing sonar, there to get some view of what's happening in that code, and then do the specific ones, do the humane assessment, and adding that after it.
It was my point saying, after doing the right views that for this organization, having something to automatize, to recreate the view regularly.
Because
this is the step, and
yes.
I didn't see that.
No, but the idea is that when they have a problem, it's usually not a problem they have. It's usually not a one-time problem. It's usually something they want to be able to look into again, and then you have already tailored it for that organization. And you can say, well, we can automate it that it automatically gives that answer and nails it, puts it on a web server, whatever.
Going into that same direction of the sonar, I still do not understand why Moose doesn't have a one-click distribution. I download, I configure, and it runs like sonar, but it's Moose actually. So it runs some
well, the
really common set of rules, and it gives
just
you something.
maybe Moose should have some tools in that aspect, but then I think one of the people who really puts a lot of effort in Moose is Doru, and Doru is really into humane assessment, and it says you shouldn't throw a general tool at the problem because it doesn't give you the answers you want.
And of course, there's simply a manpower issue that you can spend your time only once, and there is still so many things we want to improve here. That only is going to happen if there's a customer who wants that at the moment. From a research point of view, it's not a priority, so only if there is a commercial interest in doing that, then it will happen. More questions?
Well, then let's try to.
Want to show something?
Yeah, we want to solve a problem now, don't we?
Good. Do you have one?
We should ask the others one. Now, maybe if you we're out of time officially. Oh, okay. Did we take so long in the presentation? Okay.
No.
Do you all know Moose? Okay. A little bit. So you know the tricks that when you dive into Moose, that there's all ways of there's also a way of saying, okay, well, I want to really dive into this, and I want to say I want to put this in a Robozol easel, and now I have as variable the Delphi form group, and you can make all kinds of graphs about that group.
Yeah.
That's a real good thing to know, because when
But I'm convinced that the Moose ecosystem is really good. So I'm convinced about that. I saw many presentations, I tested a little bit, but it's really a good tool. But the problem I think it's missing. I don't want that people come to Moose starting from Sonar. For me, it is a fail. I don't agree with Doru or with whatever. I would like to have a one click, I install it, I say I use this parser, my code repository is this one, and it show me a seaside web page with those cool diagrams, which are the general one, and then I can say, oh, but this diagram I want green and not a red color. So I will start by that. Okay, and then I will add a new diagram.
no, but what I said,
Yes.
that's why
So
we
you want this, not Doru.
That's something that should happen, but at the moment it's the case that people like Steve Freeman who has the Smalltalk experience, who writes things about growing object-oriented software, who is really into legacy code, knows about these things, still has a problem getting started with Moose. Yeah, so that should be fixed first. If the real experts can use this, then the next step is make sure that everyone can use it.
And that's also why we started working on the Delphi parser. We want to pull Moose out of the box, saying, okay, you have a Delphi program, look, we load it into our tool, and then here you have, and we didn't show that yet. Where's the workspace? Can't use the white bar because that will take too long. Where's the then oh yeah, now it start parsing. It's this one is delayed, but okay.
We make specific views for Delphi code to help people start with that.
So for me, that's cool. What I would like is one click, say, okay, I have a Delphi repository, I enter my Delphi, and then it shows me the default views for Delphi code.
Yeah, like the origin rules.
Yes. Yes.
Then we see we have an about box, and that looks about like this. And then you can
like an outline of the.
Then you can really see. Okay, I understand Delphi, and I can drill into that and say, okay, it has a panel, and apparently I don't have everything.
Yeah.
And that panel consists only that, and I have an action list. Well, that's also. Yeah. Oh, this is probably the problem. It has an action list, but the action list doesn't work, of course.
Yep.
Because it's action list, so it's not actually a form. But then you can, yeah. So, thank you for your attention.
Thank you. Yep.